Pray anywhere, we gotta learn function, root and square. And I said pray anywhere, cause I got a lot of things to share.
Hey, welcome to another lecture. This one we're going to talk about the definition of the trig ratios, sine, cosine, and tangent. What do they mean? Okay, we're going to explore that. Let's begin by visualizing a right angle triangle first. Okay. All right. Okay, here it is. Okay, so let's say this length is 1 and this is 3. Okay. So the ratio of these two sides is 1/3, right? And if I actually introduce a similar triangle, different sides, okay, but if I extend it like that, this to this ratio, so if this was, for example, let's see, 1.5, okay, then this length here will be 3 times 1.5, which will make it 4.5. Again, the ratio of this to this will be 1/3. And if I keep doing this, as long as I actually, right, keep drawing a triangle that fits under here, the ratio of, right, this height and the base will be equal. Okay, so the key thing here is that this over this is not, the 1/3 is not the only way to get 1/3. We can do that with any size triangle. The only constant thing here is this angle. Okay, the constant thing is the angle. The lengths are not constant, but the ratio is. So we want to communicate that ratio is 1/3 given this fixed angle. Okay, so the way we denote that is the following. We say this word tan of this particular angle is equal to 1/3. So it's saying, given a particular angle, any similar triangle with this side over the base is 1/3. Okay, that's what this statement means. Okay, we call that tangent of an angle is equal to 1/3. And that angle is an angle that doesn't change no matter how big of a similar triangle you create to create the ratio of 1/3. Okay, so we need to define some names that's commonly used to describe the trig ratios. So you have the angle theta. The length that's opposite to theta, we call it the opposite side. The length that's adjacent, okay, there's two sides that are attached to the angle. The longer side, the longest side in the right angle triangle, we call the hypotenuse. And the other side, we call it adjacent. Okay, just remember, if you can't figure out which one is which, right, the longest one is always hypotenuse, take the shorter one, okay? So tangent, we just described, is a ratio formed on any right angle triangle. Any right angle triangle with this particular angle is called defined to be opposite over adjacent. Okay, adjacent. Okay, and then the ratio not only between opposite over adjacent, but even opposite over hypotenuse will remain equal no matter how big of a triangle you make. Right, this over this will be the same. Okay, we define it to be sine. Okay, sine of theta. So sine of this angle is opposite over hypotenuse. Okay, and then finally cosine of theta is adjacent over hypotenuse. Okay, this is cosine. Okay, so let's do some examples to get a little bit more comfortable. Okay, so let's say we have a right angle triangle, and it's only for right angle triangles, by the way. Okay, so let's say this has a length of 1, 4. Here's my theta. Okay, and the question is to find sine of theta, cosine of theta, tangent of theta. Okay, we're given one triangle with two of the sides. Okay, so we can find the ratio. Although, really, sine of theta is referring to any triangle with this angle and a right angle triangle. Right, so it could be the ratio for even something bigger like this. Okay. So we'll get into more of that distinction a little bit more later, but let's do this one here. So sine of theta requires the length of the hypotenuse. And for that, we need the Pythagorean theorem. So h squared is equal to 4 squared plus 1 squared. That's 17, so it's square root of 17. So sine of theta, right, is equal to opposite over hypotenuse. So it's 1 over, this is root 17. So 1 over root 17 is the ratio. Cosine is 4 adjacent over hypotenuse, so 4 over root of 17. And tangent is 1 over 4. Okay? So we'll do a little bit more advanced examples, but I want to just end it there, just comfortable enough with the definition and knowing how to state the ratios, okay? You have to understand that sine, right, and cosine of tangent, these are ratios. It's another way of writing similar triangle ratios of the sides. And we put a theta here because all of those ratios are related to one fixed angle. Okay, so that's it for this one. I'll see you in the next.